Hi, in this tutorial we're going to be looking at how we can figure out the zeros of a function. First we're going to list all of the possible rational zeros of that function and then determine which one of those actually are zeros. So when we have a function such as this first one, f of x equals x cubed minus x squared minus 8x plus 12, what we're going to want to focus on is the leading coefficient, or the coefficient of the first term, and also the constant. Now, what we're going to want to do is we are going to have several fractions. Fortunately, in the case where your leading coefficient is 1, you don't really have to worry about fractions. But on the top of that fraction, you're going to have all of the integer factors of your constant, which is 12. And on the denominator, you're going to have all of the factors of your leading coefficient, in this case 1. So what we're going to do is we are going to figure out uh, all of the factors of the numerator divided by all the factors in the denominator. Since our denominator here is 1, we really just have to worry about the numerator, since every time we divide the numerator by plus or minus 1, we'll get plus or minus the numerator. So my factors of 12 are plus or minus 12, plus or minus 6, plus or minus 4, plus or minus 3, plus or minus 2, and plus or minus 1. So those are all the possible zeros of my function. Now there's a couple ways we can figure out which ones are actually zeros. Now to save you some time, I'm just going to show you how to look at one of the numbers, two different ways here. So let's look at 2, for instance. One thing I can do is I can just simply take f of 2, and that's going to be 2 cubed minus 2 squared minus 8 times 2 plus 12. So 2 cubed is 8, 2 squared is 4, 8 times 2 is 16 minus 16, and we have plus 12. So 8 minus 4 is negative 12. I'm sorry, 8 minus 4 is 4. So we have 4 minus 16 plus 12. 4 minus 16 is negative 12. Plus 12 is 0. Surely you can figure that out on your own to ensure that it is 0. The other thing we can do is we can use synthetic division. If I put 2 up here in the box and I take 1 is my coefficient for x cubed, negative 1 is my coefficient for x squared, negative 8 with the x, and 12. When I divide this and bring down the 1, 2 times 1 is 2, so I get 1. 2 times 1 is 2, giving me negative 6. 2 times negative 6 is negative 12, which gives me a remainder of 0. So that checks out in two different ways. So 2 is an actual 0. The other actual 0, and to save you some time, I'm just going to tell you it's negative 3. If you want to verify a different number here, let's just take a look at 1. If I were to put 1 in this box to see if it was a 0, what I see happening is I get 0 here, 0, negative 8. Negative 8 gives me 4. Notice I get a remainder of 4, so 1 is not a 0. So as you can see, I have all of my possible zeros here, and underneath I have the two numbers that are actual zeros. We tested the 2. You're going to have to take my word for the negative 3. Looking at a second example here, h of x, you'll notice that this time my leading coefficient is a 2, and my constant is a 3. So I'm going to have to take all of my factors of 3, so basically plus or minus 3 and plus or minus 1, over all of my factors of 2, so plus or minus 2 and plus or minus 1. So in the end, I'll have plus or minus 3 halves, plus or minus 1 half, plus or minus 3, and plus or minus 1. So let's just once again try out one of these as an example. I'm not going to go through all of them. Let's just try one. If I have 2, negative 3, negative 2, and 3, bring down the 2. 1 times 2 is 2. Negative 1. 1 times negative 1 is negative 1. Add them. We get negative 3. 1 times negative 3 is negative 3. I get 0. So positive 1 is definitely a 0. I'm going to tell you that negative 1 is also a 0. And you will find that 3 halves is a 0. So on the left here, I have my possible zeros. And then on the right, I have my actual zeros. All right, so go ahead and see if you can figure out this example on your own, listing all of the possible rational zeros of this function. And then after the semicolon, figuring out which one of those are actual zeros.